Hello class, these are our notes for Algebra 1, section 413. Today we are looking at absolute value functions. So first we want to consider the following function. F of x equals the absolute value of x. So we have not defined absolute value yet, and I would like to talk about that a little bit. So when we write these lines around the x, it means the absolute value of x. And absolute value is the distance from 0. So if I'm thinking about 0 being in the middle over here, and I want to say find the absolute value of 3, I'm talking about how many units 3 is away from 0, and that's going to be 3 units away. But if I am looking at, say, a negative 3, well, I'm also talking about distance from 0, and so negative 3 is also 3 units away from 0. So absolute values are going to give you a positive number. I guess you could say absolute value of 0 is just 0. But the point is, because we're talking about a distance, we're not going to get a negative here. So we're going to go through and fill out a table. So first we're going to take the absolute value of negative 3. We've just said that, negative 3 is 3 units away from 0. Absolute value of negative 2 is just going to be a 2. Absolute value of negative 1 is a 1, 0, 1, 2, 3. So when you take an absolute value, you are finding a distance from 0, and it's not going to be a negative. It is never negative because distances are positive. So now we're going to go ahead and graph this function using the table. So looking at my table, when x is a negative 3, y is going to be a positive 3. When x is a negative 2, y is a positive 2. So I just graphed this point and I'm graphing this point. Next one is negative 1, 1. So when x is negative 1, y is 1. And then we've got, of course, 0, 0. When x is 1, y is 1. When x is 2, y is 2. And then when x is 3, y is 3. So we end up with this shape right here. So just to add a little bit more about our absolute value function. The absolute value, so y equals absolute value x is a v-shaped function with a vertex at 0, 0. All right, now we're looking at a word problem. So let's continue on here. Imagine you are playing a number guessing game where the guess that is closest to the target number wins. In this game, it doesn't matter if the guess is above or below the target number. What matters is how far off the guess is from the target number, or the absolute value of the difference. And we're going to call this the absolute guessing error. That's what we're going to call that. So we will call it this. We will call this. The smaller the absolute guessing error, the better. So for example, if the number is really 15, but you guess 10, it's 5 away. So your absolute guessing error is 5. But if the number is really 15 and you guess 17, you are 7 away. So that's your absolute guessing error. So it doesn't matter if you're 5 under or 7 above, whatever it is, under or over, you're going to count it as a positive because you're only looking at how far away it is from that number. So it's a lot like our absolute value that we just talked about. So 8 people made the guesses below for the number of pretzels in a jar: 14, 15, 19, 21, 23, 24, 26, 28. The actual number of pretzels is 22. Complete the table below with the absolute guessing error of each. So if you guessed 14, but the actual number is 22, well, 22 minus 14 is going to be 8. And if you guessed 15, but the actual number is 22, well, 22 minus 15 is going to be 7. If you guess 19, but the actual number is 22, 22 minus 19 is 3. Let's see, 21 is 1 away from the real number. 21 is 1 away from 22, but so is 23. So those are both equally close. One is 1 unit lower and the other one is a unit above. 24 is 2 away. So now I would do 24 minus the 22. So I'm switching the order that I'm subtracting in to make it a positive. 26 minus 22 is a 4. 28 minus 22 is a 6. So now I want to go ahead and graph my function. So along my x-axis is going to be my guess. So the guess is going to go down here. And then the guessing error will be on the y-axis. So first you give a guess, then we say how much you're off by. And so let's see. We got a label up to, I guess our guesses go up to 28. So this is going to be 2, 4, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. It's a little bit off, but this will be easier to graph even if we have one point kind of hanging off there at the end. And then as far as guesses go, we need to number up to 8. So I'm going to number my 2's here. All right, so let's see. My guess of 14 has an absolute guessing error of 8. So when we graph 14, we are going to go up to 8. Oh, you know what? I totally screwed up that y-axis. It should be 8 and then 10. Good thing we saw it. So when we have a guess of 14, we're off by 8. When we have a guess of 15, we are off by 7. A guess of 19, we are off. Oh, you know what? I think I messed this one up too. Wow. I've got 20 missing right there. Okay, a guess of 19, we are up to 3. Let's see, 21 is 1. 23 is also 1. 24 is 2. 26 is 4. And 28 is 6. So we can see our graphs, our points would lie along this graph right here, which should look really familiar. What do you notice about this graph? Well, I notice it is a V shape or an absolute value shape. So V shape or absolute value shape. I notice it has a vertex at 22, 0. So this would be the equation y equals absolute value of x minus 22. Because really whatever my guess was, we could subtract 22 and then make it positive. What are the winning guesses? Well, the winning guesses would be the ones that are closest. So that would be this point here and this point here. On the table, they were the ones that were only 1 away. So our winning guesses would be the 21 and the 23. So winning guesses are 21 and 23. All right, so this is the end of our notes, but we always like to go through and do a quick recap. So important ideas today are what the absolute value means. So remember, absolute values are not negative. They are a distance from 0 on a number line. Just this idea that an absolute value makes a V-shaped function, and it is a function. It passes the vertical line test. That we can look at this number guessing game here, something like that, and that we understand what the absolute guessing error is, and that we could go through and we could graph a function like that. All right, as always, class, if you have any questions, please make sure that you ask.